So welcome back guys. In this video we are going to study about routing information protocol, which is called RIP, and a dynamic routing protocol. So in the previous video we saw about what is two types of dynamic routing protocol, IGP, EGP, and then in this video we're going to study about distance vector protocol and the routing information protocol. So let's go further. So what is RIP, routing information protocol? And it's like a industry standard, and like EIGRP is like a Cisco proprietary. So it uses the algorithm distance vector, which means like routing by rumor logic to learn and share routes. So it uses hop count as a metric, and then one router equals to one hop. So yeah, as I told in the previous video, the metrics for each routing protocol, and the maximum hop count is 15. So any more than that will be considered unreachable. So if router takes more than 15 hops, so the packet will be dropped. So it has three versions: RIP version 1, RIP version 2, and which are used for IPv4, and then RIP ing, which is like next generation used for IPv6. So it uses two types of message. One is request, one is response. So what is request? So the router ask RIP enable neighbor router to send their routing table, and the response is like whatever the neighboring router to send the local router routing table to its neighboring router. So request, like one router asks to the second router the routing table, and then the second sends to the first. So request and response. So by default, RIP enabled routers will share their routing table every 30 seconds, but the regular updates can cause problem in a network with lot of routers. So RIP is not being used a lot in like industry. The OSPF or OSPF is being used. So yeah, so we have RIP version 1 and RIP version 2. RIP version 1 only advertises classful addresses, that is class A, class B, and class C. It doesn't support VLSM like variable lane subnet masking, and then CIDR like classless inter-domain routing. So don't worry about this, like I'll just cover this concepts in like further videos. So what does this mean? Like it doesn't include subnet mask information in their advertisement, that is in response messages. So let's take an example. 10.1.1.0/1024 network will become 10.0.0. like this is like class C, but it will be represented as class A. So 172.116.192.0/18, which comes as class B, will become 172.116.0.0. so basically this all will be get rid of. So that's the loss. And then one more example, 192.168.1.4/30 will become 192.168.1.0, which is a class C address, also assumed as /24. So messages in this RIP version 1 are like broadcast, which are like 255, 255, 255, 255, or like all Fs. Okay, so to overcome the disadvantages of version 1, RIP version 2 was being like taken into consideration or like invented. So it supports VLSM and CIDR. So it includes all the subnet mask information in the advertisement, like this address will be taken as it is in the network, not like /24 like class C will be considered as class A. So message are like you multicast to 244.0.0, as you have seen in the IP address video that multicast belongs to class D addresses. So yeah, broadcast messages are like delivered to all the devices on the local network, and multicast messages are delivered to only devices that have joined the specific multicast group. So let's see an example like how to configure RIP over here. So over here I've taken like 4 routers connected to 4 different domains, and then they each of them have connected to like 4 different networks over here. So as you go in like routers 1 global config mode, enter router RIP, and then do version 2. As you know, like version 1 has some disadvantages or cons. So and then on the next do no auto summary. So what is no auto summary, like what is auto summary? So auto summary is on by default. So for example, using 172.16.1.0/28 network attached to router 1. So this network attached to router 1 is like class C network, but it would be advertised as 172.16.0.0/16, which is class B, which is the property of version 1. So if you do no auto summary, it will take class C address. So all the time when you enable router rip, use these two commands like version 2 and then no auto summary. So later we'll just configure network 10.0.0. So like router 1 is connected to two networks like 10.0.13.0 and 10.0.12.0. So what is network command? Network command tells the router to look for interfaces with an IP address that is in the specified range. So like 10.0.0.0, like in this range these two addresses belong. So active rip on the interfaces that fall in this range. So form adjacencies with the connecting rip routers. So like this router will tell, like I have this network to this router, and then this router will tell like my interface is being connected on this network to R2 over here. So basically it advertises the network preface of the interface, and the OSPF and ARGRP networks also operate in the same way. So remember this command network. Okay, so once you do network, so because the network command is classful, 10.0.0.0 is assumed at 10.0.0.0/8. So R1 will look for any interfaces with IP address that matches 10.0.0.0/8. That is means that /8 means like first 8 bits, that is the first octet. Like because it is /8, it only needs to match the first 8 bits. So in this two networks we can see it, the both the networks matches first 8 bits, and then 10.0.12.1 and then 13.1 both match. So RIP is activated on G01, G00 and G10. Okay, and then R1 form adjacencies with its neighbor R2 and R3. So R1 form RIP adjacencies with R3 and R2. Okay, and then R1 advertises that 10.0.12.0/30 and then 10.0.12.13.0/30 to its RIP neighbors. So it will just advertise this network to over here, and it will advertise this network to R2. So similarly we'll take the network 172.16.0.0, which is connected to G20 of R1. Okay, and then in the same way as like previous, R1 will look for any interfaces with a IP address that matches 172.16.0.0/16, and then it finds that 172.16.1.14, that is the IP address of G20 of router 1. So RIP will be activated on G20. So there are no RIP neighbors connected to G20, like there is no neighbor, there is just the network over here. So no new adjacencies are formed, and then R1 advertises are 172.16.1.0/28 to its RIP neighbors. So although there are no RIP neighbors connected to G20, R1 will continuously send RIP advertisement out of G20. So like it will just send RIP advertisement like I have this two network on my routing table to this network over here. This is unnecessary traffic. So G20 should be configured as passive interface. So what is passive interface? Passive interface command tells the router to stop sending RIP advertisement out of the specified interface, that is G20. However, the router will continue to advertise the network prefix of the interface, that is 172.16.1.0/28 network to its RIP neighbors. So like there is no need to advertise like 10.0.13.0 and 12.0 on this network, but like if we like configure passive interface over here, it will not tell like this to network on this network, but this router will stop advertising on this network, but it router will tell about this network to about to R2 and R3. So that's what we need. So you should always use this command on interfaces which do not have RIP neighbors. So EIGRP and OSPF both have the same passive interface functionality using the same command. So the command is passive interface G to 0. So whatever interface you need to do, so just we need to stop advertising RIP neighbors on this interface. So what if we connect a default route to internet on G30 of router 1? So on the network 203.0.113.0/30. So the will go by a static route. So hope you remember this command of static routing from the static routing video. So IP route, that is the default route, means like 0.0.0 network, and 0.0.0 that is the subnet mask, and then this is like whatever you get packets from any network to any place, just forward it to 203.0.113.2, like to the internet. So let's see the routing table after doing the static route. So as I told you, a star plus, that is the static route, will be default route will be configured over here, so that it will tell like any like unknown network packet will come, just send to 203.0.113.2. so to that is to the internet. So in the RIP configuration, how to do it, just configure this command default information originate. So what does this do? It's like router 1 will tell like if you get any default packet, just send it to on this interface. So it will tell R1 will tell R3 and R2, and then R3 will tell R4, and then even R2 will tell R4. So that's how the population takes place. And then in the routing table we can see that R star. What is R star? R means RIP. So router 4, like routing table on router 4 looks like any default packet you get, just send it to the default network over here. So it has like came to know from 13.1, that is from router 3, and 24.1, that is the IP address of router 2 over here. So it has added 2 routes over here, and then the RIP has the adjacency AD count of 120 and the metric 6 2, that is from R1 to R4 there is 2 hops, like 1 and 2 and 1 and 2. So both of the routes are being added here, and then you can see that 34.1 belongs to fast Ethernet 2/0, so over here. So yeah, and then 24.1 is being received on G00, which is over here. So hope you understand all the RIP concepts. So I think the RIP concept is being clear in this video. If you have any doubts, just comment in the description, so under the video, so I can help you solve the problem. I think this in this video we studied RIP protocol, and in the next videos we'll study about OSPF and all. So thank you, that's all.